This video is for the extra credit portion of the CS61B NBody project, in which we were asked to add something fundamentally new to the NBody simulator. I'm Valerie Yip, and my partner is Daryl Bowie, and this is for Professor Josh Hugg's Spring 2019 class. So we added two additional features to our program. One was a black hole, which was kind of an original idea, and the other feature was a user-controlled rocket ship, which basically was one of the examples of things you could do for this portion of the project, given in the instructions. We edited both the NBody Extreme and the Body Extreme classes for these additions. The black hole object is a Body Extreme object that sucks in almost everything that's near it. The way we did this was by making its mass large enough so its gravitational pull was very strong, and when another body's position was within the black hole graphic, it would disappear. We added a method to the Body Extreme class to check if a body was in the black hole, meaning its position is within a specific range from the center of the black hole image. We also edited the draw method so that if a body is in the black hole, it wouldn't be drawn. The black hole is set to appear at a random time during the first half of the simulation for demonstration purposes, and this can be changed later. And it also appears at a random location within the frame. We did this by using the mat.random function. The rocket ship is also a Body Extreme object, but it has a relatively negligible mass in comparison to the other things in space, so it's pretty heavily affected by the gravitational pull of the other planets and things. To control the rocket, the user can use the arrow keys, and we figured out how to do this by reading the documentation for the Princeton Standard Drawing class and the Java Key Event class. We basically checked if any of the arrow keys were being pressed by the user within the loop of the NBody Extreme main function, and adjusted the velocity of the ship accordingly. So naturally, the up arrow would increase the y velocity, the down arrow decreases the y velocity, and similarly, the right arrow increases the x velocity, and the left arrow decreases the x velocity. So now I'll run some simulations of the project to show you what we did. So if I run the simulation, I see that a rocket ship appears, and I can control it using the arrow keys, and if I don't hold on to it, he is subjected to the forces of the other planets in the solar system and the sun, of course. And if I move it, I can control it using the arrow keys, and then a black hole just came and sucked everything up in it. So I'll run it again. I didn't get much time to work with my rocket there. So the rocket appeared in a random location, and basically just moving it around. And if I don't hold anything down, he'll just orbit like normal. And it's not 100% scientifically accurate because I made the rocket a little bit larger than most standard rocket ships, but I thought this looked a little bit better for the demonstration. And I can run it with a different interface. So this one has a lot more planets. That makes it a little bit harder to control, but it's kind of like a game navigating it around. So right now I'm holding up, and then down, right. Oh, I lost my rocket ship. I can get him to come back. Right, left. So, yep. And then the black hole comes and just sucks everything up. So yeah, that's the gist of the our project, and thanks for watching.